Okay, we're live.
All right. Thank you for being here. Welcome to day 3 of the 2021 Pennsylvania Virtual Turfgrass Conference. My name's Brad Jacobowski, and I'm kind of one of your co-hosts. And if you are here for your pesticide credits, what we're going to do then is we'll have 3 30-minute seminars today. All are worth points. And so with that, then all you need to do then is just to input your name, state of residence, and your certification number in the chat window. And then I will go ahead and take those numbers down, and I will share those then with the governing body that will be awarding points. So again, then just go ahead and your name as you see it on the card, your state of residence, and your certification number. And it looks like we've got a number of them doing that already, which is good. So.
I'm trying to get Jenny's presentation to pull up on my screen, but it always wants to show up on the wrong screen. So
okay.
Pause that. Okay, let me introduce the first speaker. Our first speaker is Genevieve Christ. Jenny received a Bachelor of Science degree in Agricultural Science from Penn State and a Master of Science in Agronomy from Iowa State. She is employed with Penn State's Extension's Pesticide Education Program as an Extension educator. She's involved with K through 12 education and outreach, pesticide safety, presentations, and other related educational activities. She's a certified public pesticide applicator. Prior to working for Pesticide Education Program, she spent 2 years as a Penn State Extension Nutrient Management Specialist and 4 years working for conservation districts as an agricultural conservation specialist. She also has experience with pesticide sales, research, and safety. So with that, I'm going to share my screen.
Hello everyone, my name is Genevieve Christ, Penn State Extension and Pesticide Education Program. Today I am going to present to you a pesticide formulations demonstration. So this next half an hour we're going to focus on 8 different pesticide formulations, how they work, how they interact. I'm going to use some common household items to kind of show you, how they work in the spray tank when you're mixing them up. And we're going to talk about some of the precautions that we need to take with each one and the different ways that we can protect ourselves. So there are a couple things to think about when we talk about pesticide formulation. First, the formulation itself is the active ingredient, so the chemical that actually controls the pest, and then the inert ingredients or other ingredients, as you might see on the label. And I kind of like to call those inert or other ingredients the secret formula. So we don't really know exactly what's in there. Those inert or other ingredients do not control pests, but they help make that pesticide formulation itself potentially safer, easier to mix, and just more manageable in general. So we're going to talk about the different formulations that are out there. Most pesticides are found, they're either in liquid or dry formulation. So we're going to talk about dries first and then liquids. There are some other ones that are gaseous, but they're so uncommon that I'm not going to cover those today. So the first pesticide formulation that I want to talk about is a dry product, and it is ready to use. So we use it as a dry product. We do not, add it to any other type of carrier. And so that is a dust. So a dust, again, like I said, is a ready-to-use formulation. It's going to contain a very low percentage of active ingredient. And so that active ingredient is going to be mixed with some sort of powdery inert carrier. And that inert carrier is going to be made from something like talc or chalk or clay or even nut hulls or volcanic ash. Okay, so when we think about a dust, a pesticide dust, it's going to be very similar to baby powder. All right, think about baby powder. So always use dry, just like our dusts. And because of that dry, powdery state, they can drift pretty easily to non-target sites. Think about using baby powder. How often do you actually get it only on the target? A lot of times it ends up on your shirt, on the surrounding area, everywhere. So we want to make sure that we're very cautious of wind or other weather events that might be happening, because that can affect the outcome and really the target of our dust, pesticide dust, because we want to get it on the target as much as possible, because if not, we're just going to be wasting it. They require really simple application equipment. Typically, they're going to come in the container. It's also used as the applicator. So we want to be careful when we're opening our dusts. I don't know if you'll be able to see. Let's try against the, can't. I was hoping we could see the poof of the baby powder, but I don't think we're getting to get that on camera today, but that's okay. So we want to be careful when we open them, because we can get that poof. They are dusty, so they're going to be irritating if we inhale them or if they get into our eyes. They're not going to stick very well to our treated surfaces, so we don't want to be using them on a windy day. And again, they're really hard to spread uniformly. But there are some insecticidal dusts out there that work really well. But you just have to be cautious of how you're applying them and what the environment is for that application. Okay, so that is our first dry pesticide formulation. The next dry pesticide formulation that we're going to talk about is one that does need mixed with a carrier. And so that is a wettable powder. And so wettable powders are going to be dry, finely ground formulations that look like dusts, but they have to be mixed with water for application. Typically water, I should say. There are a few times when they might be mixed with something other than water, a different type of carrier, but typically they're going to be mixed with water. So my household example of a wettable powder is flour. So flour is very much, this works very similar to a wettable powder. So what's interesting about wettable powders is they do not actually dissolve in water, but instead they form a suspension in that water. So I have a cup of water here, and I have my measuring device. So I'm going to scoop out some of my flour, and we're going to put it into our we're going to put it into our spray tank. And what do you think we need next? Agitation. I know some of you said it, agitation, correct. So now I'm going to agitate my wettable powder. Agitate. And we get our suspension. So tiny particles of that wettable powder are suspended evenly throughout our liquid carrier. But what happens when we stop agitating? We're going to let this sit for a couple minutes and we'll find out. So wettable powders are typically going to contain 50% or more active ingredient. They are one of the most commonly used pesticide formulations, and they are very economical to produce and to use, which is why we find them pretty often out on the market. But there are a few things we need to think about. One, when we open this container of flour or our wettable powder, what normally happens when you open it? You get that poof, right? So we want to be cautious that we're not opening that container with our face over it, because we don't want to get that into our eyes or into our respiratory system. We want to make sure that we're using a measuring device. It does not pour very well, right? Think about trying to pour flour. It's very hard to pour flour. So we want to be very cautious and make sure we're using a designated measuring device and not trying to pour it, because when you do pour, what happens? You end up with half the product on the counter or somewhere else and not where you want it to be. And that's just money going down the drain, I guess we could say. And one of the biggest things we want to talk about is, let's see if we can get this to show up. Yeah, you can see it. So where's most of my flour now? It's at the bottom of the cup. So wettable powders, because they do not dissolve, they need constant agitation to stay in suspension, okay? So we have to make sure we're constantly agitating our tank to keep that suspension formed, because if not, we'll just get separation, and then most of what we apply is just going to be like barely pesticide active. It's going to be water with maybe a tiny bit of active ingredient, because most of our active ingredient is going to be at the bottom of our tank. Additionally, because these do not dissolve in water, they can be very abrasive and they can clog nozzles. So one of the most important things that I want to tell you about wettable powders is you kind of want to work with them like you're making gravy. How many of you have made gravy before? I bet a few of you have. I've made it like once or twice. I'm learning. I watched my mom though growing up. So when we make gravy, you know, you have that pan of the hot, I call it drippings. I don't really know what the real word is. And then you want to add flour to it to turn it into gravy. But instead of, what happens if you put flour directly into the hot pan? You get lumps, right? Exactly. So what you want to do is you want to take that flour and you want to mix it with a little bit of water first, and you make a roux. It's basically like flour paste. And then you've got all the lumps out, and then you pour that into that pan with the hot stuff and you make gravy. Same concept when measuring and working with a wettable powder. You want to mix it with a small amount of carrier first, really mix it up well, get those lumps and clumps out, then pour that into your spray tank. That's going to save you in the long run from clogged nozzles or blocked screens or strainers or whatever you want to call them, or even clogged hoses. So yes, when you're working with a wettable powder, think about gravy and, you know, do that, kind of make that roux, that mixture ahead of time. Not ahead of time, just before you put it into the tank. You know, do it first, and that'll save you in the long run. Okay. So our next dry formulation that we're going to talk about is a soluble powder. So a soluble powder is going to look like a wettable powder, but it's soluble, which means it's going to dissolve completely in water. Okay. So, and once it's completely dissolved, it's going to take a lot of science or energy to get that product to not be mixed up or dissolved. I hope that makes sense. Like once it's dissolved, it's really hard to get it undissolved. You could evaporate it and do some other magical things, but truth is, once it's dissolved, it's dissolved. And so my household example of a soluble powder is grape Kool-Aid. I know you're wondering why grape Kool-Aid, right? Of all things. Well, growing up, this was the only Kool-Aid my dad liked to drink for some reason. And so for the longest time, I just thought grape Kool-Aid was the only type of Kool-Aid that there ever was. But now as an adult, I've learned that there's other flavors, but I still like to use grape for my demonstrations. It's just fun, you know? So when you take your grape Kool-Aid, your soluble powder, and you take your water carrier, we'll pour a little bit of that in there. All right, you can kind of see it starting to spread out already. We're going to do a quick stir, you know, just a little bit of agitation, and done. Our soluble powder is done. At this point, you know, if this was our spray solution, we head out to the field, start spraying, or head out to wherever you're going, and you can start spraying. And you don't have to keep agitating it. It's not going to separate at this point. It's good to go. So soluble powders are kind of diverse in their range. They can have as little as 15% active ingredient up to almost 95% active ingredient. So it's really important to make sure you're reading that label and understanding what type of PPE you need to be wearing when you're working with these soluble powders. They are dusty, so we want to make sure we're avoiding opening them with our face over them or opening them in a windy area. But they're much easier to store than our wettable powders, or not to store, to measure. I don't know why I said store, to measure than our wettable powders. You know, think about pouring flour versus pouring sugar. Which one's easier to pour? Sugar, right? Sugar is much easier to pour than flour. So same thing with our soluble powders. Soluble powders are going to be much easier to pour than our wettable powders. And again, once they're dissolved, they do not need agitation. They're not going to be abrasive to your equipment, and they're not going to clog your nozzles. And what's really cool is, you know, if you're working in like turf or landscaping, you could mix up a spray tank of a soluble powder, go out, do some spraying. It's lunchtime. you know, wash your hands, take your PPE off, wash your hands again, do your thing, eat your lunch, put your PPE back on, head back out, and your spray solution is still perfect and ready to go. No separation, no clogging, no problems. And that leads me to our last dry formulation that we're going to talk about today. There's lots of other dry formulations. These are just 4 of the most common ones, which is why we talk about them. But the last one is a dry flowable or a water dispersed granule. These are going to be abbreviated as WDG or DF. And basically, they are wettable powders, so like our flour, but they've been manufactured one extra step, and they've been made into these small granules instead of dust, okay? And so they're going to be mixed with water, and the granules are going to break apart into fine, insoluble particles, just like our wettable powders, all right? The concentration of the active ingredients is going to be very high in these, typically often like 90%. And one of my example, or my household example of a water dispersed granule or a dry flowable is instant mashed potatoes. And that doesn't make any sense, but you'll get it in a minute. So basically, if you've ever worked with instant mashed potatoes, I know I talked about gravy, now potatoes. I'm sorry if I'm making any of you hungry. We got our water carrier, we got our dry flowable. We're gonna pour some of our dry flowable into our water carrier. And as you can see, we've already got it kind of floating around in there, but where's most of the product? Down at the bottom. So we're gonna give it an agitation, and it's gonna form a suspension. But when we stop our agitation, what happens? It's gonna settle out, just like our flour did, our dry or our wettable powder. So you're probably wondering what's really the difference then, because they both require agitation. Well, our dry flowables or water dispersed granules are so much less dusty than our wettable powders. And so there's a lot less chance for us to inhale them during mixing or loading. And they're so much easier to measure. Think about the packaging difference. This box comes with a spout for pouring. Flour bags do not. You know, you want to dump them, you might dump them out into another container, but you're still scooping the flour out to measure it. Where this, you can actually pour it to measure it. So they're much easier to measure. But just like that wettable powder, they do not dissolve in water. So they're going to need constant agitation to stay in suspension, because you can see here, we've already got separation. They are going to be abrasive to pumps and nozzles, and they may clog your screens or nozzles. So same, you know, kind of cautions. So again, when we're working with the water dispersed granule or the dry flowable, I highly recommend mixing it up first in a small amount of carrier. Get the lumps out, give it a chance to kind of break down into those smaller particles. And then pour it into your spray tank. That'll just save you from some clogs or some headaches out in the field later. So we covered 4 dry formulations, and now we're going to cover 4 liquid formulations. So the first liquid formulation that I want to talk about is an emulsifiable concentrate. So emulsifiable concentrates are kind of unique. So the liquid active ingredient is actually soluble in oil or petroleum. And then it's mixed with an emulsifying agent, and that allows that product to then be mixed with water. And when it's mixed with water, it doesn't quite dissolve like our soluble powder, but it's not nearly as suspension forming as our wettable powder, but it creates something that we call an immersion, or an emulsion, sorry about that. Basically, there's tiny droplets of that active ingredient that's going to be dispersed throughout the carrier. It's going to require some agitation, but again, not as much as our wettable powder. And so my household example of an emulsifiable concentrate is pine sol. All right, so pine sol is an emulsifiable concentrate. So one of the things about emulsifiable concentrates is they have a very strong odor. So any of you that have ever used pine sol know exactly what I'm talking about, because it has a strong odor. The minute you open that, like everyone across the room can smell that product. Our emulsifiable concentrates are going to contain between 25 and 75% active ingredient, and they're going to be very versatile. They're going to be used for a lot of different applications. But something we want to talk about is that emulsifiable concentrates are flammable. They're petroleum or oil based. So we really want to be cautious where we're storing them. We want to keep them away from open flames and from heat. Additional to that, they are oil or petroleum based, which means they're going to easily absorb into our skin. So when we're working with these products, we want to make sure we're wearing long sleeve shirts, which we should anyways, but make sure you're wearing your long sleeve shirt and gloves so that you're protecting your hands and your forearms, because if that product does get on your skin, it's going to absorb quickly into your body. Emulsifiable concentrates can be a little tricky. They will drift, especially on hot days. They'll kind of vaporize, they'll get into the air, and they will move off target. So we want to be cautious on very hot days that we're not really near any susceptible crops. So things like tomatoes or grapes are going to be very susceptible to emulsifiable concentrates, and you can cause a lot of harm if that product moves off-site to these very sensitive species. I think that's it for emulsifiable concentrates. Moving on to our next pesticide formulation. This is actually my favorite one, and you'll find out why in a minute. We're going to talk about a solution. So a solution is formed when our active ingredient is a liquid, and it's going to dissolve readily into our liquid formula or into our liquid carrier. And so the product that we're going to talk about is cold brew coffee concentrate. And the reason this is my favorite is because coffee is always a solution in my mind. But I know, I'm so funny. So what's interesting about our solutions is basically we take a concentrated version of the pesticide and we take our liquid carrier and we pour it in. We almost don't even need to agitate. You can see from here, it's basically already done its job. We're going to give it a quick stir. And at this point, we are dissolved. It's very desirable, very easy to use product. We basically went from concentrated coffee to regular, normal people dosage of coffee. And that's kind of the same concept with our pesticide. We go from that concentrated version to a diluted version. This is a very desirable formulation, but nature does not work this way very well. And so this is one formulation that it's hard for pesticide companies to manufacture. But just to make this, like, kind of reiterate this solution, what a solution is and how well they work, think about glyphosate or Roundup. I know that's the trade name, but it's just an easy one that people recognize. Think about how diverse that product is and how many different ways and concentrations you can find it in. You know, the average homeowner can go to Lowe's and buy a 2.5 gallon jug of Roundup that's ready to use, right? It's already mixed. It doesn't require agitation. It doesn't require shaking. It can sit on the shelf for 2 years and it's still going to work because it's a solution. Or a farmer can buy a 55 gallon drum of a very concentrated formulation of Roundup and tank mix it himself. So that's kind of the diversity of the solutions is they're very shelf stable. They last a really long time. They don't need agitation, so they can sit, which makes them pretty convenient. But again, most pesticides do not mix well in the environment as a solution. So the next one I want to talk about is a flowable or a liquid. This is another unique formulation, kind of mixes the two characteristics of an emulsifiable concentrate and a wettable powder. So what's unique about this is that the active ingredient is solid and it does not dissolve in water or oil. So instead, the active ingredient is attached to a clay-like substance and then is ground into a very fine powder. And then what they do is they take that powder and they suspend it in a small amount of liquid, making a very thick product. So my household example of a flowable or a liquid is Pepto-Bismol. So what's the first thing you should do before you take Pepto-Bismol? Shake it, right? Because where's all the product, well, the active ingredient is at the bottom of the container. So the first thing we want to do whenever we're working with a flowable or a liquid is we want to shake it, because we want to distribute all of that active ingredient that has now settled out in all of that small amount of liquid carrier. Okay? And so then we're going to measure out some of our flowable or liquid. So again, it's a thick product, kind of like what I said before about our, or what I said about this. Sorry about that. Our flowables or liquids are very thick products. And so we're going to take that thick product and we're going to pour it into our liquid carrier. And where is most of my product still? It's on my measuring device. So when you're working with these flowables or liquids, you really want to make an effort to get all of your product off your measuring device. Because if not, you're going to leave half of your active ingredient hanging out on your measuring device, and then you're not going to get very good control out in the field. Once you get it into your liquid carrier, you are going to need to agitate to keep your active ingredient evenly distributed. You don't have to agitate as hard as our wettable powder, but you still need to do agitation. These can clog nozzles. So again, mix it with a small amount of carrier first, get it really mixed up and absorbed and distributed well before you pour that into the spray tank. I think that's all I had about flowables or liquids. Yeah. All right, moving on to our last pesticide formulation. Guys, we're almost done. This is awesome. So the last formulation that I want to talk about is an ultra low volume. This is also abbreviated sometimes as a ULV. So these are going to be extremely concentrated pesticide formulations. There are some of these products where the active ingredient is almost 100% of the whole product. So they're meant to be used with very little carrier. So a small amount of product is going to go a really long way. And they're primarily used in outdoor agriculture, forestry, ornamental, or mosquito control applications. And so my example of an ultra low volume is going to be vanilla. If any of you have ever baked before, when we work with vanilla, do we use cups of vanilla or teaspoons of vanilla? Right, teaspoons of vanilla. A little bit goes a very long way. And so that's what these ultra low volume pesticide formulations are like. The formulation is something that makes it's easy for us to deliver to our target. We want to just get a little bit of that on that target. And so a lot of times they're going to be used in situations where the applicator might have to cover a long distance without access to reloading facilities. So think about like pest control along a power line, right? Somebody might have to walk a long distance. They can't walk with 20 gallons on their back. That would be way too hard. So, they're going to be using a smaller tank, and they're not going to have access to reloading facilities. So they want something that you don't have to put a lot of product on the target. You want to be able to put a little bit of product on the target and then keep moving. And so that's where our ultra low volumes are going to be very helpful. And, one of the most common ultra low volumes is used in mosquito control. It's called malathion. Some of you have probably heard of that insecticide. But, our ultra low volume droplets of spray and even the product, the concentrated version, are going to be very concentrated. And so we really want to be extra cautious when we're working with this concentrated formula. We want to make sure we're wearing the proper PPE when we're mixing and loading and measuring that product. And you also want to make sure your equipment is calibrated accurately, because you're only using a small amount of product. If you're accidentally putting down twice as much as you should be, you're wasting a lot of product, because this is concentrated. So a lot of times it's going to be a little bit more expensive than some of our other pesticide formulations, but you only use a little bit at a time. So the economy to scale works, but you want to make sure your equipment is properly calibrated so you're not wasting your time or your product. So yeah, so today we covered formulations. So pesticide formulation is the combination of the active ingredient and the inert or other ingredients. Some of the most common formulations are going to be liquid or dry products. And we talked about a variety of different products and ways to protect ourselves. And as always, my reminder to you is to make sure you're wearing the labeled required PPE. Standard work clothes is long sleeve shirt, long pants, shoes plus socks. And if the label doesn't call for it, just wear the gloves. If you do anything to protect yourself, wear the gloves. Thank you so much for your time. I hope you have a wonderful day.
Okay.
Great.
Hopefully
And
everybody can hear me.
And I saw that we had a couple of questions, and I texted right now. Jenny's she's in another meeting right now, but she said she would be happy to answer those questions that were there that were asked at the open Q&A at the end. So
Right. So there were a couple questions that came in. We'll just save those for the 11:45 spot, and we can ask them then when Jenny gets in here. So next up is Jeff Borger. Mr. Jeffrey Borger is an assistant teaching professor of turfgrass weed management at Penn State University. He earned his BS degree in turfgrass science and his MS in agronomy from Penn State. He's conducted research that's focused on plant growth regulators and weed control and taught classes at Penn State for 30 years. He has, I took it off here because it was long, but it was something like 900 research reports and publications, and he teaches 7 courses, 3 in the 4-year turfgrass science major, 2 in the 2-year golf course turfgrass management program, and 2 in the World Campus program. So with that, I'm going to share my screen and get Jeff's talk up here.
So this is really about materials application, pesticide applications, and what's the plant doing? What's the growth stage of the plant? What's the maturity level of the plant? Start at the beginning, seed germination. The application timing of materials you're going to use would be a pre-emergence material. And I'm going to choose crabgrass. Crabgrass is one of the more basic types of pre-emergent herbicides to apply and control the. Now I'm going to show you a phenological indicator. There's lots and lots and lots of models out there that are very good. Okay, they're accurate. You can use them. This is just the way I do it. Okay, because it's a visual thing for me. I'm kind of a visual guy. So I'm going to show you what a phenological indicator. The definition of a phenological indicator is that 2 things happen at the same time in nature. 2 plants do something at the same time in nature. Not the same thing, okay, but something happens. If plant A is this, then plant B is that, okay? And that's where we're going with this. That's where I'm going with this. So a phenological indicator for the germination of smooth crabgrass is Forsythia petal fall. So I see something yellow. This is a Forsythia, by the way, those of you who don't know what it is. This is Forsythia, and I see the yellow, I see yellow flag. That says it's time for me to get ready to do a pre-emergent application. Because it's not until these petals really start to fall off that the crabgrass is going to germinate. So what's the problem with this? There are problems with it, okay? The crabgrass is here, let's just say. This is where our crabgrass is. You need to get down and take a look, see if crabgrass is germinating there. Well, obviously, you can still use a model, but even if you're using a model from some area, you still have to confirm that it's true. It's not to the second right. Nothing is. But when you're looking at phenological indicators, so here's all this Forsythia. All right, now it's petal fall. Okay, this is the flower. Okay, of the Forsythia plant. This is not when it's going to germinate. When the petals fall off of this, so it's starting to fall off here. The litter. See the green coming out. So phenological indicators. It's petal fall of Forsythia. Smooth crabgrass is probably going to be germinating. But again, if we're trying to look at a pre-emergent herbicide, you want to get it down prior to the germination process. Okay, unless you're using some different chemicals that will actually control single leaf stage crabgrass. Is that petal fall? Is this petal fall? Okay, there's no good here it is. This hour of the day is when petal fall is. This is when the crabgrass is going to. Let's talk about a time to apply pesticides at flower production. Basically, the plant is changing morphologically, and it's going to produce a seed head, a flower. Any plant, not, this is just in general, okay? So I'm going to tell you that the actual time that the plant is putting the flower on and making the flower, okay, until it is pollinated and falls off, right, is not the best time to be applying herbicides for control, elimination of the plant. Remember, perennial plants flower also. Annual plants flower. After they flower, they potentially die, most likely will die. So, it's a whole catch-22 thing. Don't apply pesticides for control until after the flowering process is done. And directly after the process of flower production is one of the better times. So here we are, magnified, huge magnification, right? It's easy to see the flower on this, this is a henbit, okay? It's real easy to see that flower. Dandelions, think about dandelions, it's real easy to see their flower. And a lot of times, especially in the lawn care scenario, clients see a dandelion and are like, oh man, I need to control this, right? Yeah, but just wait till the flowering process is done. Well, all the seeds are now going to be viable. So you still have, it's a catch-22 scenario. When do you do it? How do you do it? How long does it take to get you there? So let me talk about how a plant grows here, right? So at flower production, right, this is our grass plant, okay, plant X. And this particular plant, we're going to have a flower or seed head being formed right here. It's going to come out of the crown, out of the growing point, it's going to come out. Well, this plant has to change how it grows and where it diverts its energies to that growing point so it can produce a flower, a seed head, all right? So let's look at it like this, all right? So here is okay, so let's look at it like this. So this represents the carbohydrates and sugars of the plant. The plant is going to make all of them, most of them, a lot of them, go upwards in the plant. It's going to travel this way. It's going to go from the growing point, it's going to go to that seed head, it's going to grow to the leaves, the stems, whatever's there. Right? This is the mode of growth that the plant is in. Now, if you apply an herbicide, basically the herbicide is going to follow that, more of that herbicide is going to follow this stream than going down to the growing point and or to the root system, especially if it's a taprooted plant, which is what a dandelion is. It's a taprooted plant, okay? So, the herbicide has to work really, really hard in this analogy to get to the growing point of the plant and to the root system of the plant because the plant's trying to produce a seed head. What does it look like when a plant is actually being controlled? It's called epinasty. It has a name for it. So you can see here, this is common or broadleaf plantain. It's cupped, it's twisted, it's curled. This seed head has got a hook on it. This seed head back here, it's all just, there's something wrong with the plant. It's not growing properly. Now, the phenoxy herbicides do a lot of this. Okay, the phenoxy herbicides, the group of phenoxy herbicides. The reason they do is because the reason the phenoxy herbicides make a plant look like this, others do also, but the reason they look like this is because when a plant is under control via a phenoxy herbicide, one side of the plant's cells are going to grow faster than the other side of the plant. Basically, the best way to kind of think about it is the plant's going to grow itself to death. That's, again, not true. That's just a way to think about it. So that's what causes all this twisting and curling, cupping. It's just the change of how the cells grow. And the phenoxies are not notorious for that. Now, what happens, and this is our plant annual bluegrass, Poa annua. what happens after the flowering process, right? So Poa annua, a winter annual, okay, it will produce the seed head. Take a look at the seed heads in here. This is magnified a little bit, right? Right here's the seed head, right? Once the seed head is done, matured, fallen off, okay? Shattered is what they call it. The plant has been really, really stressed with its metabolism because it's done everything it possibly can, because this is, when it's a true annual, but when it's an annual plant, this process is, I produce a seed, the plant will regenerate itself because this plant is going to die off. So is the plant going to die off? Annual bluegrass, that's another whole animal we'll talk about later. But look at it. Now, this happens in May here, right? Because it's a winter annual plant. So a lot of times we're going into the stress of the season, June, July, and August, and this plant may or may not have recovered from the seeding process, because although it's a winter annual, it acts like a winter annual. Annual bluegrass in State College, Pennsylvania, and in this climate will be a lot more similar to a perennial plant. Okay, so let's just think about all that. Let's go to a dicot, white clover. Again, white flower on white clover, it's all here. That's a honeybee, that's not white clover plant. So what happens is the white clover plant is putting all of its effort into producing this flower and seed head. Now, first thing that comes to mind for me is golf course fairways. White balls, white seed heads, flowers. Yeah, that's you're going to slow play down potentially if your golfers actually land on the fairway, or if they're out in the rough or whatever. There's white clover, makes it even harder to find a ball. Plays is slowed down. So naturally you're going to say, I see that white flower, I am going to apply an herbicide to get rid of it. But that's the wrong time. Remember, all of the fluids or all of the growth carbohydrates, whatever, of the plant is being put into efforts of producing that flower. Now, white clover is a perennial, okay? So, do you wait? Do you spray and spray and spray? This is a call that the manager has to make for the situation that you're in. In theory, if at all possible, if you could wait till this plant is done flowering and then apply your herbicide, you'll get better control. Dandelions. I talked about this earlier. Lawn care people see dandelions. Right? The clientele see the dandelion, the yellow flag, come get rid of these broadleaf weeds in my yard or whatever the site is. But the thing about these are, as you well know, is this seed is windborne. So I just told you that the best time to apply an herbicide is after the seeding process. Well, that's after that seed moves off the site, possibly with the wind. So you're just repopulating the site. Doesn't matter if it's clover or annual bluegrass or dandelions. What I'm telling you to do is leave the seed, a viable seed, come back to the site. So it's not a once and done thing. You have to think about a complete strategy here. That's why we're talking about different growth stages in plants. So look, it can be done, right? You can control dandelions. This is up by side of one of our research stations. Actually, beaver steam's right over here. But look at those dandelions versus look at them here. Okay? There's the spray line. So what happens if this person says, I don't care, and the wind blows in this picture from left to right? Well, the seed's coming over here. You can see there's a dandelion over here, right? It's not perfect. Right? So the seed's going to come here. So, you have to think about all the ramifications on this. If you're a lawn care person, you say, wow, this is the neighbor's lawn and this is the lawn I'm taking care of. That dandelion population is coming over here because we have this, westerly wind all the time. Is it a good thing or bad thing? Bad for your reputation, good for the fact that you're going to have lots of stuff to take care of and come back to. Right? All situational. This is actually a pretty good time because juvenile plants aren't producing a seed, okay? They potentially, if they're an annual plant, they don't have a very good root system, right? Even if they're not an annual plant, you know, a really young dandelion plant doesn't have a fully blown taproot system in place as it germinates, right after it germinates. So it's really a good time to apply herbicides for control of them. Now, back to our old buddy here, smooth crabgrass. Just because the plant's small doesn't mean it's a juvenile, right? So, you know, here we are, crabgrass plant at different stages of growth. There's a 3-leaf stage of growth, okay? There's maybe 6-leaf, I don't know what it is, stage of growth. So you have to make sure that, are the plants all at the same growth stage, first of all? How does this plant really grow? Is it like this crabgrass plant, and this is a late germinated seed, you know, and it's September? Well, this plant's probably never going to see the light of day. So you have to think about the situation before you say, oh, this is what I'm going to do at this time. Think about the growth situation. And the growth stage of the plant is really significant, especially when it comes to smooth crabgrass, okay? Where different herbicides work differently. Now, this is post-control. This is post-emergent control of smooth crabgrass. So if you were to look right here, the drawer is turned down. But if you look right here, you can say, oh, this is 3-leaf stage of growth. If that's all you saw, I mean, you can see it back here. Here's 3-leaf stage of growth. Now, in the scenario of smooth crabgrass control, that 3-leaf stage of growth and tillering stage of growth is a dividing line of what products will and won't work. So 3-leaf stage of growth and earlier, there's a group of products. Okay, 1 to 2 tillers, which is basically a seed head, is another group of products. Okay, so here we are. If you look, there's 3 leaves, but it's actually tillers. See the tillers down here? So that's 1, 2, 3. That's 4 tiller stage of growth. But if all you did is look at it here, it's like, oh, that's 3-leaf stage of growth. You could actually be using the wrong herbicide at the wrong time, because some of the herbicides that work well at this 2, 3-leaf stage of growth don't work so well at the tillering stage of growth. Right? So growth stage is important by way of what product to use. Is it juvenile? How juvenile is it? How mature is it? The other thing I need to talk about, especially when we're talking about juvenile plants or young plants or just even small plants, and I never thought this to be a real issue until I actually saw it happen, where we didn't get some control. I call it Canopy Interception, right? IPM, see the weed, right? Integrated pest management, right? It's you know, all about how am I going to get this product to the plant. And I've got a line drawing here to show you what's happening. So again, let's just assume that this is our crabgrass plant and we're at 3-leaf stage of growth. Now, potentially at 3-leaf stage of growth of the crabgrass plant, it won't be any higher or much higher at all than the desirable turf grass it's growing in. So this desirable turf grass, because this plant sometimes will get rosette growing flat to the ground, especially when it gets seed heads on it and it has room to do it, this area of the leaf might be reduced because of the desirable grass that's there. So if you apply an herbicide, and this is just for the thought process of it, if you don't apply an herbicide and this plant's real small, it's not growing above the top of the grass plant that's there, maybe you only get this much herbicide, this yellow area of herbicide on the leaf. Now, these post-emergent crabgrass herbicides are foliar absorbed, along with other things, but they have to be foliar absorbed also. So if you don't have very good coverage on the foliage, you're not going to have very good control. But even if you're applying the right material at the right time, right? So this growth stage is an issue. Now let's look over here at this plant. This is obviously a much bigger plant, and the crabgrass plant is going to grow above the level of mowing for the desirable turf. And if you spray the material on here, you know, you're going to get lots of coverage. Now, if you're not spraying the product, but you're using a granular herbicide, you need to get it to the soil. So it doesn't really matter how high or how big the plant is relative to the stand of turf, right? If you're using a granular material. If you're using a foliar absorbed material, it does. So you have to, you think about it. Are you going to get a good enough coverage? Good enough. intercepting area of the undesirable plant. So let's just move a little bit further. All right, we're talking about stress, both environmental and mechanical stress, and herbicide applications. This is a really, really poor time to be applying herbicides. The plant has defense mechanisms to make it survive the environmental conditions. Obviously, they're not foolproof, but they're there. So here's a shot of our research facility. And here's where, so we drive equipment up and down this area, and these are testing areas. You can see this. So this plant, this is tall fescue. Look, it's not brown, it's not dead, maybe not as healthy as it could be because of all the stress, but it's summertime and it's under stress. All right, it's under direct stress from cart traffic. All right. How about mowing? All right? I've shown this picture many, many times. It's very old, but it's very true. So remember I talked about canopy interception? So these weeds, these dandelions, right? They're mowed down or scalped down. That's stress. You just put this plant, not only did you put the grass plant in stress, you put the weed in stress because you've mowed it so low, or mowed it often enough so low. It's just not going to work for you. Stress, mechanical stress, environmental stress. Environmental stress. Now, I want you to take a look at this. Yes, this is drought. Right? These plants have shut down. The grass plants have shut down. They basically went dormant. Okay? The grain plants are Buckhorn Plantain. Now they're really easily spotted. Right? And you can say, wow, I need to go spray an herbicide. I don't care about the grass. I care about this Buckhorn Plantain plant, and it's green, it's growing. Yes, it is, but it's under stress and it's growing differently than you would suspect. It's not a good time to be spraying any herbicide on dormant turf, okay? But especially if you're trying to control a broadleaf weed, especially Buckhorn Plantain. Now, I want you to take a look at the plant. Look how shiny, this is not a doctored photo. Look how shiny this leaf surface is. There's a reason for that. What happens when a plant goes into stress? Not always, but some of them will produce a seed head. Right? Look at the seed head on the Buckhorn Plantain plants. Right? It's going into stress. So it's going to produce a seed head. So two things are happening. I'm going to talk about the shininess. That's one of the issues. But the other issue is the plant says, I'm going to make a seed head. So all the metabolites are moving towards that seed head. All the growth compounds to make the plant grow. All the carbohydrates and the sugars are going as proportionally speaking to the seed head. Right? It's not going to grow. Or it's not going to be very. So I want to conclude here with this is basically the bottom line is you need to evaluate everything. How does the plant grow? Is it annual? Is it perennial? Is it biannual? Is it, summer annual, winter annual? I've even heard the term anytime annual, meaning the plant will germinate no matter what season it is. That's not a scientific term, but I've heard it. How does this herbicide work? Is it a pre-emergent that forms a barrier? Is it a pre-emergent that goes into the soil, the top quarters of the soil? Is this post-emergent herbicide something that's absorbed through the foliage, or is it only absorbed through the root system? Or is it, how's it predominantly absorbed into the plant? Is the plant actively growing? What does actively growing mean, right? An actively growing plant that is in drought stress is not actively growing. And I showed you reasons why you don't want to apply an herbicide. Post-flower production. Seed head shatter, post-flower production is actually not a bad time to try to eliminate the plant if it's a perennial, okay? Realizing that you now have seed added to your soil bank, your soil seed bank. Okay? Just because you eliminate that plant doesn't mean you're not going to have something else germinate. Bottom line, you just have to think about everything when it comes to, and I'm talking about broadleaf or grassy weed control, but this applies.
Jeff, I don't know what happened to your thing. Maybe that was just the 30-minute mark that you had set for your talk, but
I think some of it got cut off. That's okay. I'm not real good with electronics. Let's put it that way. I'm an old man.
I'll give you 30 seconds to summarize your talk. Put you on the spot.
Okay, 30 seconds. Think about growth stage. Think about what the product you're using. We had a whole really good presentation about formulation and product types. Well, think about that, okay? Because the type of product you're using, how the plant's growing, where it's growing, it's annual, perennial, whatever, all play a role into effectively control.
That was an interesting talk, Jeff. I really enjoyed that one. Thank you.
You're welcome. Glad you liked it.
We do have time for questions if people want to ask Jeff any questions now. We can also wait until into the end. I still say that we don't have Jenny on here, so she hopefully will be here before.
She will be. I did text her with the questions that were asked of her, and so she has those, and she'll be happy to answer those. I think at the open Q&A at the end.
Okay, I'm going to. Dr. Mcgraw is up next. Let me get my Wienermobile.
So just also as a reminder, for your pesticide credits, please input, if you haven't done so already, put the name as it appears on your card, the state of residence, and your certification number. Appreciate that. Okay,
this is the second talk that Dr. Mcgraw has given this week. But I'll give a brief introduction. He's an associate professor of turfgrass science at Penn State and an authority on the ecology and management of turfgrass insect pests. He obtained a Master of Science degree in entomology from UMass Amherst and a doctorate in entomology from Rutgers University. Dr. Mcgraw's research focuses on understanding insect ecology and behavior to develop sustainable turf pest management practices. With that, I'm going to turn it over to you.
Good morning. I'm Dr. Ben Mcgraw of the Turfgrass Entomology Lab here at Penn State University. Today we're going to be talking all things earthworms, and we're going to provide an update on some of the studies that we've been conducting over the last 3 years here at Penn State. So 2020, as everybody is aware of, was a really challenging year with the global pandemic, and it was very challenging for our laboratory as well. Many of our long-term project plans had to go by the wayside as we were very short-staffed, especially early in the year when earthworm castings were beginning. However, that didn't stop the production of casts in our research plots or anywhere else in the Commonwealth of Pennsylvania. And so what we had to do at that time of the year is really decide what was important to keep, and we felt like this would be a long-term study where we could look at castings over many, many years. Instead, we had to make some hard decisions about what we kept in, and we did keep in some of the more important things, in our opinion, such as looking at the long-term benefits of top dressing. And casting was, it was pretty erratic this year. However, the fall season, casts were very consistent, and they persisted for quite a long period of time. This is our research plot in December on the day that we were installing some soil sensors for next year's studies on these areas. And you can see that the casting is very, very heavy, even through a light dusting of snow. And when you look at it at top, these casts are actually melting the snow around them. So very heavy casting. This would be actually in an ideal situation that we would have earthworms under snow cover, aerating the soil, mixing those layers up, doing all the benefits that they do. However, my fear is these plots in springtime are going to be pretty problematic. It's for mowing purposes. They're going to be very, very muddy surfaces, a lot of smearing, suffocating the turf, and all the bad things that come with earthworm casting. So as I alluded to in the beginning, we have a multi-year study ongoing, and its future remains a little bit unknown based on some of the findings that I'll be presenting today. But this was an area at Valentine that had very consistent castings over the years. And what we wanted to do is look at various cultural control inputs such as fertilizers and top dressing, as well as some adverse effects that some of our pesticides have on earthworm densities, as well as their cast production. So these plots are 3 foot by 3 foot plots. They're replicated throughout the area. They're randomized so that we don't have a heavy earthworm casting area where it's all the plots are congregated. So essentially, what we're trying to do here is some pretty good science. And as part of looking at these effects that things like cultural practices have on earthworms, it's very important to withhold any sort of inputs from these areas that would normally be going on. So I think of this as a typical bent grass fairway plot, and we maintain them as much as we can as far as fairways, but we're not providing any sort of dollar spot control or anything like that to keep the turf alive. We are solely interested in the earthworms, and we're solely interested in their casts. And so that fecal matter that they deposit on the surface is measured every week by putting down a grid and counting the total number of casts in that area. So I'm going to show you a lot of slides like this, which show you some pretty jagged up and down cast counts. So the y-axis would be the density of casts within an area, and running along the x-axis would be the date. And what you can see in the 3 years is pretty erratic from 1 week to the next. We have high weeks, we have low weeks, and a lot of this is determined by the environment. So I'm just going to give a brief summary of really what we would see in these plots, or we could even think of this as what we would see in this research fairway if we did nothing. No sorts of controls or inputs whatsoever. These graphs represent our untreated controls. What we saw in the first year of our study is really massive rainfall in 2018. So very short spring. It was about 4 weeks long of casts that we observed. And we also saw some pretty intense casting in the fall, despite that wet weather that we had through much of the year. Really intense casting in the fall period, more so than the other years. In 2019, what was different from 2018 is that we had a much longer spring. So that duration of casting was a couple of weeks longer, now 6 weeks, but we did, especially in the springtime, received very ample amounts of rainfall. So 2018, the whole year was wet. 2019, about halfway. That allowed us to see some casts during the summertime, which is somewhat unique. Looking at these 3 graphs, is typically we have no casting whatsoever in the summertime. And then 2020, the pandemic year, if you will. Very short spring, again, similar to 2018, about 4 weeks long, very droughty, as we all remember from summer and very far into fall. But we did have some very consistent densities of casts throughout. So these 3 graphs would represent what earthworm casting would look like on the surface if we did nothing to it. Now, another thing that we're going to see as I show you the control charts throughout time here is we have to deal with this variation. This is a problem to scientists. You see these error bars on top of these dots would kind of encompass how accurate our estimations of the casts are within these different treatments. So the bigger the error bar, the more variability in the data from one, let's say, thiophanate methyl plot to another thiophanate methyl plot. So we like to see those error bars really small. We also see that it's really erratic from 1 week to the next. So this is, again, an untreated control doing nothing whatsoever. And you can see a steady decline in springtime. So that poses a problem if we're trying to compare a treatment to doing nothing to see if we're actually having an impact. And so one solution that we come up with is we tell our computer programs to estimate the area underneath the curve. So disease scientists or pathologists use this type of analyses where they want to see, is dollar spot more or less than in these 2 different treatments. So this is very handy. This area under the curve, we can compare a treatment to an untreated control just by looking at the area that falls underneath that average line. Another thing that we have come up with in our time of doing these studies is looking at thresholds. And so being an entomologist, I think, where we deal with trying to maintain insects below a certain level, the threshold approach has worked very well for earthworms as well. And what we've arbitrarily come up with is this idea that if we can keep casts below 5 casts So 5 little individual casts in a meter square, which is about a yard by a yard, or a half a cast per foot square. Pretty much nobody's going to notice. It would have great benefits. It would be a great place to keep that under. So if we're looking at our 3 years here, 2018, 19, and 20, and looking at the untreated controls, what you can see is that in springtime, we need about 1 month suppression from whatever practice we're trying to do to reduce problematic earthworms or casts. And in the fall, what we see in each of the years is that the fall is more dense as far as casting, but it's also a longer season. So what we need to have is something in an ideal world that provides suppression for about 2 months. And possibly if we can control the fall generation earlier in the fall, maybe that the duration of casts that are above threshold is much shorter. All right, so let's look at some of the findings that we've had over the years. Fertilizers were one of the things that went out the window in 2020, as far as most of them. We did have some trials that have not yet become public that will probably become public in the next 6 months or so. But as far as some of the more generic, if you will, types of fertilizers that we have used in the past, or what we scientists have believed in the past provide suppression of earthworm casts, include things like acidifying fertilizers. Ammonium sulfate and iron sulfate were looked at over a 1.5 year period in this 3-year plan, where applications were made at 2 different rates over 3-week intervals. So every 3 weeks, we were making applications of one of these rates, and we were comparing that to the untreated control. Another thing that we've looked at over the years are saponin-based fertilizers. So the products Early Bird and Rhizoaid are both low nitrogen products that have these saponin components within the fertilizer, things that are found within the natural world that have been shown to suppress earthworm casts. So what we look at first here, the acidifying fertilizers. Now there's really there's 4 treatments, 2 of each type of fertilizer. They're in the black lines. The red line is the untreated control for your comparison. And really what we see with just glancing over it without any sort of analyses whatsoever is that these things are really not different from the untreated controls. And in fact, if you look early in the spring, you see that those lines are all above that red line, increased amount of castings in both the ammonium sulfate and the iron sulfate plots, as well as in the fall in that October-November period. And so if we ask the computer to calculate the area under these different lines and then compare them to the untreated controls, what we can see with the ammonium sulfate is we saw about 17 to 24% increase in casts. And the real striking thing is when we do our soil sampling 2 to 3 times a year, we didn't really see any sort of reduction in pH. And that's because these soils are, they're really, really heavy soils and very difficult to buffer. All right, so what does it look like as far as the saponins? As I mentioned, saponins are natural components found in many plants across the globe. And when you put these components, or you crush them up, grind them up, put them in water, they form a soap. And that soap is able to be applied down through the soil profile, comes in contact with the earthworm. They have very mucousy exteriors, so that's going to drive them to the surface. And so they do have a little bit of nitrogen. That's essentially how they are considered a fertilizer, but it's really this soap forming action that does the work. What we saw in many years, either in a spring or a fall application, is we get about 40 to 46% suppression of casts following the application of either an Early Bird or a Rhizoaid. And this is fantastic. This is, most people would think 43 to 46% is not a great reduction, but this is oftentimes exactly what we need to get below threshold. The other thing that is important to know with these products is that it's not a lasting effect throughout the season. In fact, if you make sequential applications, you're going to be much better off as far as reducing the herd, if you will, culling the herd, if you will, reducing that over time. So we get about 3 to 4 weeks suppression, and that's because the earthworms will mate, they'll form cocoons. And if we apply these products when cocoons are present, then it's only going to take a couple of weeks for those cocoons to hatch, juveniles to emerge, and casting to reappear. Some people will tell you you need to be prepared if you are using these products, as it's often problematic as far as removing worms from the surface. So unlike some adverse effects that we can have with fungicides, where the earthworms essentially expire within the soil, these earthworms come to the surface and require removal. However, the big story at this time in 2020 is stocks are really dwindling because of Chinese tariffs. I'm not even sure. I get a couple of calls a month about where people can find these products, and to my knowledge, no distributor really has these in stock at the moment. So the Chinese tariffs have had a big impact on the availability of these products, and it's really uncertain whether or not Ocean Organics or Brandt will continue to produce these products in the future. It's rather unfortunate because it's a very effective tool that we have in earthworm management. Our other area that we will be talking about today, apart from our chemical control studies, but our final cultural practice, is sand top dressing, and the idea of whether we should be sand top dressing fairways as far as earthworm control. Now, there's been a lot of people that have invested very heavily in sand top dressing. We've looked at it over a couple of years at two different rates: a light top dressing rate, which was made in two applications, one in spring, one in fall, for a desired total of a ½ inch, versus a heavy sand top dressing program, which was two applications in spring, two applications in fall, to achieve 1 inch, and we're comparing that to not top dressing whatsoever. Now, just so that people are aware, these are the types of soils that I'm dealing with at Valentine Turfgrass Research Center. Very heavy soils. So really sprinkling, a ½ inch to 1 inch on the surface, what is that really doing to an earthworm that could possibly be living as far as 4 or 5 meters down into the soil? So very far down into the soil. All right, so I'm throwing a lot of slides up here all at once, and really what we see across the top row is the untreated controls, so doing nothing, low through the middle row, and then at the bottom row, the high top dressing rate. So really just using your eyes, you can see that the pattern of castings looks very similar if we go down a column from untreated, low top dressing to the high top dressing rate. So what your eyes will see is pretty much what I'm going to tell you as far as statistics, but let's take a closer look at that. Here is year one, 2018, and we're comparing the area under the curve between the untreated, the low top dressing rate, and the high top dressing rate. And they look pretty much identical. The trends are exactly the same. Your eyes are not deceiving you that there's really no effect. However, if we ask the computer to look at the area under the curve for the whole season and compare that to the untreated control, what we saw is 17% more casts produced in the low top dressing rate and even greater in the high top dressing rate. Now, this is something that has been seen with southern earthworms, possibly some more native species as well as some Asian species, whereas in the Commonwealth here, we're dealing more with European invasives. But this has been seen with other earthworm species. If we move forward, looking at 2019, what we can see is, again, the casts look fairly similar. What we see in the springtime in the top dressing rates is actually quite a bit more, significantly more casts being produced, and we see even greater. Now we're going into 2 years. So one thing that I should mention is the same plots are used year after year after year. So we're really seeing a cumulative effect over time. So in 2020, I started getting a little impatient with the effects of sand top dressing. And what we decided to do is jack this up by 4 times. So now our low treatment was twice as high as our high treatment in the previous year. So we went up to 2 inches there. And with our high rates, we went up to 4 inches. And we use the same frequency of application. So we're just really bumping this up to really kind of move this along, as we were thinking that we were doing very little to the earthworm population by only looking at the very top of the profile. So here's what we saw. We saw, again, a pretty big increase in casts over time. Definitely not a reduction in casts. We're now at 3 years in, and it really doesn't seem to make much of an effect. So again, higher amounts of casts in the high casting population there compared to the low. So if we put this all together, what you can clearly see is in no year did we ever dip below what doing nothing would do to earthworm casts. So a very consistent trend throughout time. 2019, the two top dressing rates were pretty comparable, but 2 out of the 3 years, what we did see is the high top dressing rate had greater amounts of casts than the low top dressing rate. So it could be that by applying sand, we're actually irritating the earthworms, causing them to cast more because they have to forage more. The other thing that we see is a real short-term effect of casting. So these increases that we can see that cause to increases across the year in the top dressing versus the untreated, we can also see immediately following application. So all of the blue arrows here show when top dressing was applied, and I'll move my picture here, and you can see one in October. What you see immediately following that is an increase in casting in those sand top treatments. All right, so one thing that I will mention at this time is even though we do see an increase in casting, these casts have different qualities about them essentially. Here's a top dressing treatment. You can see it's very granular. That's going to disperse into the canopy a whole lot better and become less problematic over time, opposed to something like this very globular non-top dress plot cast. So it's wet, that's going to smear and suffocate the turf quite a bit. All right, we're going to move into some of the adverse effects that some pesticides have on earthworms and some of the things that we've looked at in these long-term studies, mostly as positive controls, as we know that these products can suppress and have some very adverse effects on earthworms. And I guess because I'm an entomologist, earthworms fall to my responsibilities because it's been long known that insecticides have adverse effects on earthworms. They have a very similar nervous system to insects. And what we can see is some of our contact insecticides have been used in an off-label sense for many years. Things like Carbaryl, many of you know it by the trade name 7, or chlorpyrifos, which is known by the trade name of Dursban for most people. But also, some of the neonicotinoids, as well as products that have a pyrethroid and a neonicotinoid component to them, will also be used to try to suppress earthworms. All right, so let's look at Carbaryl first. Carbaryl is pretty much, the gold standard if you're making a European crane fly application or probably trying to control some surface active insects and hopefully getting some earthworm control in the process. Let's see what Carbaryl does. What we saw as far as Carbaryl in our studies where we were looking at 6 fluid ounces per 1,000, these are crane fly rates, bill bugs, black turfgrass attenuus, or annual bluegrass weevil. I don't think those are great products for most of those insects, but that's possibly what it could be used at. If you were applying that and then lightly watering in, what kind of effect would you have? What you see is the white squares are the Carbaryl, the black dots are the untreated, and you can see some differences throughout here. First, in the springtime, with springtime applications made when you first see casts, we saw immediate suppression of earthworms for about 1 week, and then they bounced back. In September, we saw the same thing. We saw a pretty good suppression, and then they bounced back in about 3 weeks. Now, at least in May, what we see, that 1 week suppression is really nice. However, if the casts are coming back within a week, that to me suggests that it's not really doing anything to control the earthworm. Most likely, the earthworms probably can sense the residues and are avoiding that until those residues wear off. These things are very ephemeral; they're going to wear off fairly quickly. So what we can see here is, that impact was pretty severe, and then it starts to tack up at the same pace that we see in the untreated controls. However, here is another year. This was 2019, the last year that we had Carbaryl in our trials. And what we could see is, we made that application, immediately suppresses earthworms, and then they bounce back. But if we look at it from a threshold-based approach, we're keeping it below that 5 casts per meter square or a half a cast per square foot. And that might be good enough for the spring season, especially in the 2 of the 3 years where that season was only 4 weeks long. All right, let's turn our attention to fungicides. Fungicides such as thiophanate methyl have long been used for things like dollar spot control, and it has also known adverse effects on things like earthworms. So we'll look at thiophanate methyl. Early when we did these trials, we were looking at applications, one in spring, one in fall. Basically treating these 2 seasons as separate entities and not really treating it in a yearly kind of annual allotment. We would apply these products and allow them to dry on the surface, and what we'd see is pretty fantastic suppression of casts. So if you were out there making a dollar spot application in an earthworm heavy area, you might see a reduction in casts. We did use 6 fluid ounces because that was purported to us as what people were using across Pennsylvania. However, we now know that those are not what's allowed on the label. But man, here is our plots at Valentine with some pretty moderate casting. I wouldn't say this is super heavy casting, but what we can see is that those areas where are bare, you could walk through there and pick out the thiophanate methyl treatments. So with the 6 fluid ounces, if we look at it as an area under the curve in that 28 year, so here's all 3 years. The red is the untreated, blue is the thiophanate methyl, and you can see at least in that first year we were making 2 applications per year, reductions of 73% compared to the untreated control. You can see 2019, very, very high control. So we're continuing on in these same plots where we treated them aggressively, and in that first year. The following year, our reductions are excellent. We figured out the appropriate rate to use for the spring or the fall, that should say the fall there, with 91% control at 4 fluid ounces. So we basically have done the heavy lifting earlier on in this trial, and it allowed us to really see an effect of lower rates over time. So in 2020, we finally got with the program, and we're on the right annual rate, which is 4 fluid ounces per 1,000. And we had already moved the population to a lower density, and we can see an 89% reduction compared to the untreated control, and very far below that threshold. So really some excellent activity there with thiophanate methyl. Now we wanted to look at lower rates. Basically, we are bound by 4 fluid ounces per 1,000 on fairways for the entire year. So what can we, if we're thinking of earthworms as a 2-season type of problem, we need to think about using either lower rates or, that one maximum label rate for the year. So in red, and this is a very psychedelic looking graph here, but in red is the untreated control, blue is 1 fluid ounce, 2 fluid ounces in green, and then 4 in purple. And what you can see from these numbers, obviously more is better. But we can also see, if we look at it from a threshold approach, that 2 fluid ounces, even though it's providing 55% control, it's really doing a bang up job for us as far as keeping populations below threshold. So with the 2 fluid ounces per year, With an application in spring and an application in fall, we were keeping it well below. This 4 fluid ounces was actually made in spring as well as in fall. So again, that wouldn't be something that you could legally do for earthworm or for dollar spot control on your property. So again, we need to be thinking about when is the most important time of the year to be applying and really our rates. All right, I'm going to diverge into a slightly different topic here. In 2018, we saw some problematic areas in Western Pennsylvania, native areas just collapsing, no sort of anchoring of the plant. It was like a toupee laying on the surface. And what we found within those plots were slugs. This is the first time that I had ever heard of slugs damaging mature turf. And this is the marsh slug. Slugs are very, very similar to earthworms in many regards. Some of those similarities include, their mucousy skin. So they're going to breathe and urinate through their skin, which requires them to be in really moist environments. They're nocturnal, if you will. They'll come up to the surface at night and feed. And their control, it can also be very similar to earthworms, which is similar to insects. So some pretty interesting findings there. And we got on this path of trying to control slugs in these native areas in Pittsburgh. One of the things that we found to be very effective are baits. So these baits, you see these blue pellets in the turf, kind of sprinkled through the turf. There's only one product that's labeled, which is called Ferox. It's a sodium ferric EDTA. And the slugs come to the surface at night, they ingest it, and it controls their populations. Very, very effective. Now, why I mentioned this with our earthworm studies is that I came across this paper in Oregon where slugs are problematic in seed production, is that these baits were being applied to control slugs, but earthworms are getting in the way. They were coming to the surface, eating the bait, and causing slug problems to outbreak. So really fascinating study, but we thought, hey, could we use Ferox as a form of earthworm control? We looked at 2 different applications this fall. So basically, once cast started going, we applied these products. In the red line, you see the untreated control. In the black dotted line and in the dashed line, you see the Ferox at 2 different rates. These are fairly heavy rates of the baits as well. And just by using your eye, you can see that, yes, does seem to be somewhat an effect, at least in the first application, but basically no major impact. If we look at area under the curve, the low rate was 43% decrease with 2 applications of Ferox. The high was 16%. These could just be sampling anomalies, but what this suggests to me is that there potentially could be something there, but really at 2 rates, at 2 applications at these rates would not be a sustainable approach to earthworm management. So I think we're going to continue to look for solutions in similar organisms such as snail control to possibly provide some novel ways of controlling earthworms. So, what does the future hold? It's unlikely that our future products are going to have adverse effects on the worms that we have in turfgrass. One of the problems is this stage right here, the cocoon. Is very much impervious to any type of control that we throw at it, whether it's chemical or cultural. I think that future earthworm control is really going to require managing the food source. We've tried that by diluting the thatch that earthworms could feed on, but more importantly, I think the microbial partners that earthworms hold within their gut that are required to break down their food is really what needs to be targeted. And I'm not sure that that's really an area where we want to open Pandora's box where we're controlling microbes in the soil. However, the cocoon stage is a very important stage, and that's really where we're shifting our attention. Our laboratory is really kind of describing this, trying to figure out when they're hatched, when they're produced, so that we can target what controls we have now at them. All right, with that, I think I have a couple of minutes for questions. I will take any questions, and I will put up my acknowledgments here. So thank you for your time and your attention.
Thank you, Ben. Another good talk. So that was good.
I need to get rid of your background there. I was trying to have a nice Lego. We do have time for questions. Brad, do you know if Jenny was going to be able to be here by 11:30, or was she planning on it at the 11:45 slot? Because I don't think we're going to. I think we didn't have a lot of questions in between, so we wrapped up.
Right. I'll go ahead and text her right now and see if she's available now versus 11:45.
Then maybe you can answer the question, since you just talked about pesticide applications. One of them was mixing WDG formulations. I don't know if you see that question, but it said, the question was, what about pre-mixing WDG before adding to the tank? I add water, then the product into a 5-gallon bucket. It just seems to settle to the bottom and end up like mashed potatoes when they pour into the tank. Thoughts, Ben?
For me, I mean, I think with the insecticides that are WDGs that we deal with, you know, I mean, with any insecticide, and I'll speak to insecticides, I think it's always a good policy to have half your spray tank filled up, add in small amounts, start that agitation. If you know that that's a problem, that you're going to end up with the mashed potatoes at the end of the bucket, probably getting that half in and then incrementally adding it as it agitates. So I don't know of too many people who that in a smaller application setting, like for a backpack sprayer, something like that may be important, but I would still say those ratios would be important to maintain.
Yeah, I don't think it's much different from a fungicide standpoint, in the sense that, you know, if you take a bucket of a little volume of water and put in all the material at once, you're going to have a huge slurry. So you kind of have to do it slowly, or add small amounts to a tank that's being agitated and let it go. The products are different. Sometimes they're more of a pain in the butt than others. So you kind of have to do that jar test, right, with the amount of product that you have relative to the amount of water, and make sure it's going to go in the solution properly. So
I did just get a text from Jenny. She said she would be able to jump in, so she'll be here in a minute or so.
Okay. The other question, I got to go back.
Was where do you find the formulation on a pesticide label? Was one of the other questions that I remember being up there. And normally we find it right with the title of on the title of the label, don't you, Jeff, Ben, John?
Yeah, I mean, like something, it would be the product name, and then, you know, for an example, a common insecticide being like Acelepryn G versus Acelepryn SC. Even in the title of that trade name gives you some information about, you know, whether it's a liquid or a solid, a soluble concentrate. WDG, like Merit WDG, would be a water dispersible granular. So it would tell you the formulation, also whether it's a solid or a liquid.
And sometimes it's not necessarily in the title, like Heritage TL, right? TL doesn't have anything to do with the formulation, but if you look under the active ingredients, I'm looking at a Banner Max label now, and it lists Banner Max as an emulsifiable concentrate, where it says how many pounds of active ingredient per gallon are there. So it's usually on the first page of the label, either after the name of the product, like Ben said, or somewhere written near the active ingredient.
Welcome, Jenny. One of the questions that we had, I guess we've got another one here, but otherwise was, if you can see that one there, can you please discuss further how to premix a WDG before adding it to the tank, etc. on some of those?
Yeah, definitely. So we highly recommend just using, you know, a 5-gallon bucket's really kind of big. If you can do it in a smaller container than that, and use some sort of agitation device that is dedicated solely to working with pesticides. So whether it's like a yardstick or a big whisk or something like that, then you can reach into that measuring device or that bucket and really get that water dispersed granule mixed up. It's going to take a little bit of muscle to do that, but that's going to save you in the long run from any kind of clogging or issues in the end. Does that make sense?
Yeah, and I think that we mentioned before you came in here too, not to put everything you're putting into your 300-gallon sprayer into the bucket, do it in incremental steps.
Yes, you want to do everything in steps, and each one, anything that is going to require a little bit of premix with your carrier, do that separately first and then pour in. And there's an acronym for how you mix stuff in your tank. It's WALES, W-A-L-E-S, and I should have been more prepared and had that pulled up what exactly that means. But there is, a step-by-step technique that you can follow when you are doing your tank mix.
And there's another question for you, I think, about thiophanate methyl. Are there differences in the different products of T-methyl formulations, or do they most work within that group with the same results?
Yeah, we haven't really seen any differences. I know that there's, some people will say, God, we don't get any control with that. And I always say, wow, that's like our best product that we see in our trials. So there could be some differences. I think the rates on the labels are all going to be fairly similar. We use a generic thiophanate methyl. John, you would probably know more than I would if there are any on-brand versions, but for the most part, they're generics. They're all going to have about the same active ingredients. Their rates are going to be fairly similar. As I was texting with John, I'm dealing with a group in the Dominican Republic, and they have very different looking products with slightly different AI. But when you look at the label, the amount of active ingredient being applied for something like dollar spot is going to be the same. So, without testing every kind of formulation out there or every, product out there, without knowing that, I can't really be sure. What I can say is from our trials, what works really well is using a liquid formulation. We apply it to the surface and we let it dry. We don't irrigate it in. So that's another advantage that, at least in the golf course world, that we see.
Let's see.
Yeah, I don't have any much to add on that. I think from a thiophanate methyl from an earthworm standpoint, it seems like they all work. I get this question a lot with algae too. People talk about chlorothalonil and the zinc formulation being the only one that controls algae, but that's not true. They all control it. There has been some work though, maybe Fidanza did it, I don't remember, but most of the products, generics in trade, most of them are made by the same people and then just sold off. But there are subtle differences where some people are making different products than others. And so formulation can have an impact on control, but I haven't seen it with thiophanate methyl.
Jason,
I would extend that. Oh, sorry.
Oh, sorry.
I was just going to say I'd extend that to insecticides too. It's very hard to see differences, especially things that work really well. I mean, if you're looking at a difference between 95% control and 85% control, that's probably not going to be visible to people out there.
Let's see. Jason had he had a comment kind of in a question. I think it was talking about the labels. Some manufacturers do have that information right under the active ingredients, but others do not. Some have it under the product information. Are there regulations to that, or is it just you just need to at least have it listed on the label somewhere?
Reality is formulation is not even a requirement of the label. So there are certain things that are required of all labels, and there are certain things that need to be on that front page, and then the rest of it is just, wherever the manufacturer feels to put it. And reality is formulation is not a required thing that needs to be put on the label. So it's a little confusing and hard, and I guess that some of the labels do put it on there. They'll list it somewhere in there. You can also reach out to your manufacturer, and sometimes you can just figure it out based on the product that you're using and how you're supposed to mix it in.
Do you still recommend a jar test if you're mixing formulations and things like that?
well, definitely should always jar test something that you're not familiar with.
Okay.
And then I saw Jason said, is it required in records? Formulation is not required in your records, just as long as you have the name of the product, the percentage of active ingredient, whatever else that's there that is necessary. Formulation is not required for record keeping.
Cool.
If there's any more questions, we obviously have 2 more days of conferences left, and I don't want to make.
We did
Go
get
ahead.
another question here. What's the best timing for T-methyl applications to help prevent earthworm damage? Early spring, early fall, or after damage is being seen?
Well, I mean, what we're really talking about is dollar spot applications here. So along those lines, if you could somehow time that with first cast, you know, if you're looking at just T-methyl, then we're definitely bound by that 4-ounce maximum for the year. So in you know, our trials this year, even though it's just 1 year, the 2 fluid ounce looks pretty good. It's not dynamite. You're really gonna have to make some decisions. I think most people who have been on a property for a while understand whether or not they have severe casting in spring or fall. Most people in this region, it's most severe in fall. That's the time of the year, though, that golf is starting to trail off. So it may be more important in spring to avoid that. So it's kind of a toss-up. It's kind of a personal preference there. Our research would say it would be best used in fall. However, you know, there might be some products that you could use for controlling insects that would give you a little bit of a boost in fall. So, you know, I was kind of thinking about dividing it up throughout the year.
What's
Overall,
what was the timing of? I couldn't remember where your blips were in your spring. When did you start seeing those castings?
Yeah, I mean, it's kind of all over the place. We've had casting as early as March, the first week of March. I'd say typically by April, first week in April is usually about a good time for most of the years that we've seen, probably 5 or 6 years here in Pennsylvania where we've done trial work. So middle of March to early April covers most years. You know, 1 year we had very late casting. We had our first cast like in May. I think that was 2019 or 2018, one of those 2 years. So it's definitely temperature dependent. That's one of the things that we're really trying to get a handle on, is coming up with developing models for based on soil temperatures, so that you can go out and monitor and know exactly when those applications should be made. But really our lab is really focused on moving towards more cultural practices. I don't think that future products, whether insecticides or fungicides, are really going to touch earthworms. So, you know, we're trying to be a global partner here too, so that we can travel the world and give talks in the United Kingdom and whatnot. So, you know, you talk about going even to Canada, they're not going to have products that are going to touch earthworms. So really the future is in kind of manipulating the soil. We're going to be looking at things like phrase mowing and deep verticutting and stuff like that. But in order to do that and be effective, we've got to know when are the most amount of cocoons produced, when are juveniles active.
Okay. We do have a couple more questions here. So another one I've got here's one. Is there an online database for quick reference guide available that can be utilized to check incompatibility between products?
I admit I am not aware of one, so if somebody is aware, please, you know. I know that a lot of times if there is a major incompatibility, it will be listed on the label. But, you know, we really do recommend that jar test, not just for incompatibility issues, but also for your pH and your water, because your water quality will affect how your chemicals work. And sometimes doing that jar test will actually help you to know whether you have a water issue if you haven't taken the time to get your water tested. So we do recommend the jar test, not just for pesticide and fertilizer incompatibilities, but also for how well your water is going to help that perform. And
Jenny, can you touch on what should people be looking for when they're doing the jar test? I mean, what are some of the giveaways in terms of compatibility and not?
Yeah, so basically any type of change. So whether that jar feels hot or cold, that is a sign of incompatibility. And if it would like coagulate or like turn to like jello consistency almost, or if a gas would be formed or a participate, so you would see like flakes of something floating around in that jar. Those are all going to be signs of some sort of incompatibility. And if you're trying to find a specific issue, you want to take your time, you want to do it slow, add one product at a time to see if there is any change. And if you continue to have questions, definitely talk to your chemical dealer, because they're going to be able to help you maybe figure out more what specifically your incompatibility issues are.
Okay.
We could do a whole talk on incompatibility at some point.
Great.
Someday. Maybe we should do that someday.
We've got a couple more questions yet. So another one, is there any research on tank mixing the T-methyl for hours at a time? Example, 4 hours of agitation before spraying, let's say for dollar spot. Is there anything like that?
Yeah, so the one that comes to mind is thiram. People were mixing T-methyl and thiram, which is another fungicide. Our research has shown that really that combination is not better than either of those components individually. So thiram is another one that could possibly provide some suppression in addition to your dollar spot program. So thiram is has less effect on earthworms than T-methyl does. However, those things really seem to be quite incompatible with very extended periods of agitation. I think it's around like 6 hours. I would typically say don't be mixing those things if that's your target dollar spot, that is.
Gotcha.
It looks like another question from my former student, Kristen Dull, World Campus Extraordinaire. Is there a study that shows correlation between geographic location, southern exposure, slope, grade, and earthworm density? I would say yes. A very astute question, Kristen. Well done. But I would say that's what we typically see is them in hollows. So, with several of our turfgrass insects, we see the same thing. They're lazy. They like to roll downhill, walk downhill, stuff like that. But I think that's probably more of an effect of moisture, where moisture is going to be adequate. So the big driver with this group is going to be moisture. They need to have their skin. Their skin's really mucousy. They breathe through their skin. They urinate through their skin. Pretty cool. But those things require really kind of adequate moisture. And when they don't have that moisture, they'll go very deep in the soil. So I would say those things more so. I would suspect southern exposure would be drier and just not something that they'd like.
Anything else?
Okay, I don't see any other questions. If there's no more, then I want to just thank the speakers, Ben, Jenny, and Jeff today for their presentations. And tomorrow, Brad, do you know who's on tomorrow? Me and somebody else.
I've got the schedule here. So it's leading off with Mike Fidanza on fungicide AIs for fairy ring control. Then we've got John talking about anthracnose, and Tanner Delval from PSU. He's going to be talking about new options in turf management and the use of drones. So
okay, so hopefully we'll see people back tomorrow, and we'll make sure everybody's pesticide credits get submitted. And we are still waiting to hear back from GCSA credits, but hopefully we'll have an answer for that before the last day of the conference.
Correct.
So with that, I'm going to stop it. And thanks everybody for coming again today.
So thank you, everyone.